Okay, this is the third video about Lewis structure of covalent compounds. In this video, we're going to talk about Lewis structure of something we're quite familiar with, okay, such as oxygen gas and the nitrogen gas. Okay, let's look at the oxygen gas first, okay. Since there are only two atoms, okay, oxygen, it's going to make it look relatively simpler, okay. But let's look at total valence electrons. Is going to be 6 for each oxygen. Okay, oxygen has 6 valence electrons, which is 2s2, 2p4. Okay, and then there are two of them, two oxygens. Okay, so in oxygen gas molecule, there are 12 valence electrons in total. Okay, now two oxygen atoms, let's sit next to each other. Of course, in order to be in one molecule, okay, it has to be bound. So there's one bond connecting them, okay? By putting down one bond, immediately should -2 here. So because you already used 2 electrons here, so you have 10 electrons left over. Since there's no surrounding or central atom, okay, it doesn't really matter which oxygen you want to work out first. But the only thing I want to emphasize here is you have to work out one atom and then work on next atom. Just like in any other Lewis structure, okay, you can't just go around atoms, work out, average out the electrons. You have to make sure one atom is completely fulfilled by octal rule, and then you move to the next one, okay. So it's this one. So it doesn't matter which one first, okay. Let's say we want to work out the left one. It's not hard to see that this one currently has one bond, okay, next to it. So it needs 3 more pairs in order to have 4 pairs in total. So this is what this oxygen will look like. Alright, so by taking 6 dots, okay, now your -6 equals 4. Now it's not hard to see this 4, all these 4 electrons will go to the other oxygen, okay. Now don't try to evenly distribute the 5 and 5 since you have 10, okay, so you have to work out one with 4 pairs, the other one look like you have nothing left over, but this oxygen apparently is missing a pair, right? It has 1, 2, 3 pairs, but you don't have any more electrons. So the only way you can work out is you can move one of the lone pair of the other oxygen, okay, to be shared as another bond. The point is, the dots are exclusively belonging to one of the atoms, where bonds are shared between the atoms. Okay, the more bonds you have, then it will make it look like more electrons you have in total. So by moving this to one of the lone pair, it doesn't really matter which one of the lone pair, okay, to bonding pair, so the overall Lewis structure will look like this. So let's look at the one oxygen we got 6 lone pairs before, okay. So now it has 2 lone pairs and 2 bonding pair, so that still count as 4 pairs. But to the other oxygen, it has 2 lone pairs and 2 bonding pairs as well, so you got 4 pairs as well. In this case, I won't show you. You can have 2 bonds between atoms, and we usually call this double bond. As just for comparing, okay, anything like this, single dash line, okay, they are called a single bond. So these are 2 new terms we just run here: single bond, double bond. Okay, I mean it's very easy to see. It's 2 bonds in between. That's called double bond. There's only 1 dash line. That's 1 bond. Double bond obviously is composed by 2 pairs of electrons. Okay. Now, what about nitrogen? Okay, you can pause the video here, try nitrogen out by yourself, and then now we can come back to work out together. Okay, nitrogen has total valence electrons of 5 each times 2 equals 10 electrons. Now, there's one nitrogen, there's another nitrogen, connect them. Okay, -2 equals to 8 valence electrons. Again, don't put 4 electrons on each side, okay? Put all the electrons this nitrogen needs first, so 3 pairs. That will -6 equals 2. Okay, this nitrogen will have the rest of the 2 electrons, but no more. Okay, so apparently the nitrogen on the left is quite happy, but the nitrogen on the right is starving. Okay, because it's only had 1 bonding pair, 1 lone pair. It's missing 2 pairs. So what the solution to this is going to be, the other nitrogen will move 1 lone pair to be shared. Okay, so it will look like this. But still, the one on the right has 1, 2, 3 lone pairs. Still not enough, so this nitrogen will share 1 more pair. Okay, so the overall final Lewis structure will look like nitrogen, nitrogen. Okay, so for both nitrogen, it's got a 1 lone pair and 3 bonding pairs, so 4 pairs. So is the other nitrogens. But you can see this, there are 3 pairs of electrons being shared as bonds. This is called a triple bond. Okay, so there's possibly single bond, double bond, or triple bond. Okay, and you can see most of the time when you're forming double bond or triple bonds, it's because you don't have any electrons you need. Okay, so by sharing more electrons will make it look like it has more electrons. You only form double bond or triple bonds when you have to. Okay, otherwise you try to avoid these. Okay, don't automatically form double bond or triple bonds.